Right, let's start this thing. Hopefully the sound's all working. Let's get a bottle with a cork in it. So here's we got here then. Music plays and you can hear me. Okay, good. And I've got all the fans on in the room, so it's nice and cool as well. Here we got Andy Magic Knight, Prince Phase, Amok, Twin Zen, Old School Coder, Prince Phase, I've already said, Jace, I'm trying to remember as I go down the list, Eldritch, Stepz, Buzzley, yep, hi guys. Yeah, where's Hayes? This is for Hayes. So I wanted to do this stream because Hayes has had some issues getting his head around the Vic banking stuff, so we're going to have a look at how to do that. God knows where he is though. The beginning bit he really needs to know about, so try this one out. Oh god, that's very sweet. She's got an interesting label. It's an interesting one. It's quite nice. It's very sweet though. No, it's a white. Oh, I'm not wanting to see my laptop. Okay. That's the beast of a laptop. And it's very cool because you can. It's a full touchscreen down here. You can drag things into this window as well. A bit easier if I drag it with here. I don't know if you can see that. But yeah, it's pretty cool. I like it. It does get very hot as well. But it's nice. I don't know if you can see that profile. The lid creates the kind of it lifts the laptop up, so it creates a nice kind of airspace underneath, which is good. It's very good though, and both screens are 4K. So the bottom one is 4K wide and 1100 high, I think, and the top one is a full 4K screen. Okay, so what I want to do is I want to explain how the Vic banks work. If Hayes isn't here soon, I'm just going to start anyway. You can always catch up on the VOD. He doesn't have to watch it live. Just going to explain kind of how the Vic reads data, and then I'll show you some uses for playing around with the Vic banks, some of the kind of cool stuff you can do. We're going to do a demo effect called Tech. It's one of the earliest demo effects that people were doing way back at the beginning of the C64, but it's a way of creating much more than 8 pixels of scroll left and right for doing shimmer on things. So I'm going to create a folder in here, which is where we can do our stuff. So this is episode 27. Made a file called Start, so that's where we can put all our stuff. Sublime editor on tabs here. Sublime Editor. Actually, I prefer VS Code, but I've just got so used to doing it. Hang on, I feel like I'm missing something here. What am I missing? Oh yeah, that window. Okay. That one. There we go. Right. There we go. Okay. I've got a smart bulb in here, and I think it's broken because every 5 minutes or so it just flickers off for a split second. So every now and again you'll see it flash and then come back on. Oh God, it's very sweet. That I'm sure it's like a dessert wine. That. I mean, this interesting though. 19th century crimes. Creatures 3 code. Hey Fry, welcome to the stream. Okay, so let's talk about the Vic banks. Let me find a C64 memory map, so I can explain it a bit easier if I can show you with a picture. Yeah, that looks pretty good. Let's go with that one. Oops. Oh, why is that not dragging over? What is going on there? There we go. Okay, so this is how the C64 memory is divided up. So the CPU can access 64 kilobytes of memory, and it can also, well, it can only ever access 64 kilobytes at one time, but what it accesses in then those locations is based on how you have various flags set up. Generally, the flags are 0, 0, and 0, 1. I'm not going to go into detail about those. I think we've already covered those quite a bit, how to turn a kernel on and off, how to turn basic ROM on and off. And the same goes for turning RAM and char ROM and IO area on and off. But the reason I bring this up is just to show you what happens with the VIC. So this is what the 6510 sees. But what the VIC sees is only 16 kilobytes of this at one time. So the VIC can access one of 4 VIC banks, and these VIC banks are basically 16 kilobyte blocks. So they start from here to here, so this block here, then from here to here, here to here, and here to here. So they go from the FFF. These are comments. Is that text big enough? Should I make it a bit bigger? There we go. And the VIC can only look at one of these at a time. It can't look at multiple locations at the same time. This is the reason we have 256 sprites. It's the reason we have room for 8 character sets in any VIC bank, because the amount of memory, 16 kilobytes, is 64 bytes times 256. So that's why we have 256 sprites. And if you change bank, you get another 256 sprites and 256 sprites and so on. So technically you can have Tetris Drive Shallow Mad. Evan Tetris Drive Shallow Mad. Okay, that's quite loud, quite loud. What? Evan Tetris. I don't know what you're saying there, Stepz. Have you been drinking? Oh, okay. Ah, okay. Yep, let me put that on. Go. give you a tiny bit more volume for that. You did a simple pick. So I've created a character set which I'm going to demonstrate the banking with shortly. Can you hear that sound? Can you hear that music okay? I think it's a bit quiet. Oh, is this? Oh, it's this one, isn't it? Yeah, you're right. I get what you mean there. It's a bit weird, that one. So the way this works is you define using D018. So let's bring the other memory map up. For some reason, I can't drag. If I drag too quickly, it doesn't drag the windows over for some reason. Sorry, not D018, D00. Yeah, so the bottom 2 bits of DD00 define which bank you're using. Now, rather annoyingly, this is called bank 0. But to use this, you set the bits 1, 1. So you actually set that to 3. This is bank number 1. And you set these to 1, 0. And this is bank 2. Set this to 0, 1. And this is bank 3. Set to 0, 0. Pardon me. It's a bit weird, that one. So once you set that value, anytime the VIC needs to grab information, it grabs it from this range. Now, the information that the VIC needs to grab is the following. So, sprite data, screen data, character set data, and if you're using bitmaps, then bitmap data as well. Color RAM is not included. Color RAM is always in a special area, which is this bit here. It's in IO RAM. It's always in IO RAM. This is the only time that the VIC actually reads something that isn't in RAM. Otherwise, it will always... That's not true, actually. It will read RAM in most cases. It's set for color RAM. And it's set if you try and read anything from 9000 to 9FF, which I'm going to put here, or 1000 to 1FF. So I'm going to put a note here. So VIC always reads RAM at a given address, except for... So if you put anything in these 2 locations, then it's going to read character ROM from here, which is a bit annoying and it can cause a problem. It's why you will see... I think I've got some weird setting on my mouse. Hang on, let me just check my mouse because something keeps pressing incorrectly. Yeah, keep pressing Q. I think one of these buttons is assigned to Q or something. Okay, just have to avoid pressing that. Which is why if you try and use this bank here, I'm going to put star next to these. I'm going to put the star here as well. And these banks. Then you have a block of 4 kilobytes that are not very useful because it's always going to read character on here. So even if you put sprites in RAM at these locations, those sprites won't show that sprite data. They will show data from the character on. Given address, thank you. Now, this means that, and this is why I like to use bank 3 for all my stuff. This means that if you put sprites under IO RAM here, under this area, where the color RAM is, where the SID is, where the VIC registers are, the VIC2 will always read the sprite data from there. It will always read whatever is in the RAM underneath those areas. So it's a really good place to use that. No, exactly, Buzzley. There is no conflict. So the only reason why the VIC reads data from D800 to DFF is when it's grabbing colors, and at that point it will grab it from the IO RAM. In all of the cases, so for all of these things, it will read it from RAM. It's only the color data that it gets from that area. And if you put something under that area, so you can put something at D800 to DFFF in RAM, and you can have that separate from the color RAM. So color RAM is 4 bits per byte. The upper 4 bits are basically discarded, and you can't trust them to be anything. It depends on what machine you've got and how it's registered. In some cases it flickers between a few different values. But the RAM in that location is 8 bits. It's the color RAM is a special chip, basically. It's a special 4-bit chip that is line 14, right? Yeah. I mean, I'll put capitals in there. So when you select a bank, this is what you need to think about. You need to think about, do I need to use the entirety of my bank, in which case it's probably not a good idea to pick bank 0 and 2. And can I use this area here, because the area under D, the area from D00 to from here to here is not much good for code. Great place for sprites. Because you can put code there and you can run code, but you would have to bank it in all the time. Whereas the VIC will always, no matter how you've got the banking set up, the VIC will always see the RAM there. So what's at these places is a char-rom copy. And it's worth noting that only the VIC will see char-rom at those locations. The CPU does not see. The CPU sees RAM at those locations almost always, with this slight exception of this memory where it can see cartridge ROM if you've got it banked in. How do you select RAM to write into D800 instead of video RAM? So to do that, you use the value in 0, 1. So you'll see in here, if you set list value, where is it? Character RAM visible, RAM visible in all 3 areas. There you go. Set this value here, and you get RAM at D00 to DFF. If you want to copy the character ROM, so if you want to copy the character set, then you would turn the character ROM on at that location as well, which you can see in this memory map here. So you can turn the character on here. It's a very special location, this, because it kind of has 3 things that can be there, depending on how you bank it. But what you would do is you would set your banking to allow RAM at this location, then copy your sprite data into there. This is why Packer like Xmizer is really good, because you can do all your testing in Vice with injector RAM turned on, and then you can just use a packer which will reduce it down to under here somewhere so it all fits into RAM, and then the packer will handle turning the correct banking on to store the data in the correct areas of RAM. So that's how the kind of memory is set up and how you would decide which block to pick. Now you can only pick one of those 4 blocks, but what you can do is you can alternate between them at any time you want. So you can do that halfway down the screen. One common thing you might see is a game showing its main display in one bank, and then switching to another bank with a completely different character set and a completely different screen for the HUD at the bottom. Sometimes it's just a screen and a character set swap. Sometimes it's a completely different bank. So you can switch these up, and we're going to do some stuff Actually, what we're going to do is all going to be in one bank, but we're going to switch screens and character sets in there as well. And so that brings me on to the next part. So this is just one value. So this is selecting a Vic bank. Yeah, you're right about this music. It does every now and again get a bit louder. So once you've got a Vic bank selected, there's a couple of other values you need to set. So one of them is, I think it's D016. What's this? Oh, this is what Andy sent me. Oh, is this? Ah, okay. See what you're saying now. Yeah, there you go. So this is what Andy's done for. Hayes, and you can see he's set the Vic banks out, and you can see where they start and where they end. Yeah, so that's cool. Just primary. Yeah, indeed. So the first thing you need to know is what mode are you in. So it's important to know what mode you're in, because if you don't know what mode you're in, you won't know where various things are going to be. So selecting a graphics mode, D011. And multicolor D016. So why is this important? This is important because there are two primary kind of formats for the Vic data to be laid out. So there is character mode and bitmap mode. So if I just open, the debugger, these green blocks here tell you what mode you're in. Now, the top one is the most important one. So this is what tells us whether the Vic is going to be reading data as a bitmap or it's going to be reading it as text. So in text mode, you have a screen, which is 1 kilobyte. So it's just less than 1 kilobyte. By default, actually, shows nicely in the little map that Andy did here. The default is at 0400 and runs up to around about 0800. It's 24 bytes less, but it is roughly that. And your sprite pointers are always in the last 8 bytes of that 1 kilobyte block. So if your screen is at 0400, then your sprite pointers are going to be at 07F8 to 07FF. Likewise, if you move your screen around, you can see here you can move screens around. So in any Vic bank, there are 16 possible screen locations, all 4 kilobytes apart. And whenever you change the screen, the sprite pointers are in the last 3 blocks of that. You can actually no, you can't see the sprite pointers in here. So I'm sure there was a thing for showing it in here. Also in text mode, you have a char set. The char set is 2 kilobytes. Takes up 0800 bytes in hex, which means you can have 8 of these. 8 of these in any given Vic bank, basically. So that's how text mode works, and that means you need to tell the Vic where to find these things, and that's what D011 is about. So if we look at D011 in the memory map, this one here, D011 is the mode, D018 is where we set these things. Let's talk about the modes first. So that's text mode. Text mode is a 1K screen and a 2K bitmap. A 2K character set, sorry. Bitmap mode is a bit different. So if we're going to bitmap mode still has a screen. Char set does not matter. Char set doesn't do anything at this point because you don't have a character set in a bitmap. But screen does matter. Screen is where the colors are stored. Because when you're in bitmap mode, you have two color RAMs. You have the color RAM and you have screen RAM, which is used as a color RAM as well. Text mode, character mode, yeah, they mean the same thing. Just catch up with the chat a little bit. Yeah. So in bitmap mode, you still have a screen RAM, still 1K, but it's used for defining colors. It's used for defining the other two colors in every block. So with normal text mode, you set a color for a character using color RAM, and then you have two multicolors which are shared throughout the whole screen. In bitmap mode, you don't use those two multicolor values. What you do instead is you set your individual colors using color RAM, and then you set the two colors for each square individually using screen RAM. So screen RAM becomes like a second color RAM, if you like, for storing these values. Never checked chat. I do check chat now and again. Yeah, I'm not keen on this one. It's really, really sweet. And a bitmap is 8 kilobytes, so you only get 2 of these in each bank, and you can see these here. So if I switch these bitmaps around, and you can kind of see I've got the fonts here, and this is what I mean about the VIC chip seeing char ROM at these locations. So my bitmap is at 00 and it's 8K, so it runs from 0000 to 2000. So from 0 to 2000 in hex, 8 kilobytes. And that means it crosses that boundary that we've had here, this char ROM. So the VIC, when it gets to that point, will only see data that's in the char ROM character set, which is why when we switch a bitmap to 00 to point to 0, we see a character set here. And this is the char ROM copy that I was on about. Now, it doesn't matter what we put into 1000. So if I go in here, so if I put something before 1000, so say I go to this point, and I fill from 0800 to OFF with FF, so and you can see how it's filled this in red. If I want to fill the top in, check, probably can't fill the top in, let's just do, see I've changed the pattern there, but if I try and do anything in this bottom area, it won't make any difference because the VIC will only ever see that char ROM. So do the same again. This time I'm going to try and fill this area with the same pattern. And you can see I can't see it, and that's because when the VIC gets to that point, the only thing it can see there is that character ROM, which is why it's completely useless to put graphical data in that location. This is why when you see SID tunes, they're usually at 1000 because it's a really good place to put code, basically. So people use 1000 for music because it's just a common area that all games or all programs have free for code. The same reason you might see SID tunes at 9000 as well. And so that's what a bitmap is. So a bitmap is 8 kilobytes of data plus a 1 kilobyte of extra color RAM. So that's 9 kilobytes for a bitmap versus 3 kilobytes for a screen and a chart set. So a bitmap takes about 3 times more data than an equivalent character ROM screen. Hey ZXBecky, and hey Zinlow as well. And Doc as well. Hi. Okay, cool. So that's what you do. You set your mode here. So this is D011. So if we look at D011, there's a few extra things in here, but the important thing is this bit 5 here decides whether it's text mode or bitmap mode. So it's text or bitmap mode. So if you're ever in a program and you're thinking, okay, I'm I'm in bitmap mode and I should be in text mode, then it's bit 5 at D011 that you need to set. Now the other modes that are in here as well, I'll quickly explain. This is extended background mode. So extended background mode is a special character mode. Sorry to go back in here. There we go. So it's a special text mode, and what it does is it allows you to have extra colors per block, but what it does is it reduces the character set down to 64. So what it actually does is when you poke a value into the screen, so say you put the value 63 on the screen, it discards the top 2 bits. So you can go up to the number 63 and the top 2 bits haven't been touched, but the moment you start using the top 2 bits, instead of it showing you character 64, for instance, if you try to put character 64 in, you'd actually see character 0, but then what it does is the top 2 bits define which background color it uses. So it's a sneaky way of adding extra kind of background colors in, but it does reduce the character set quite a lot. There aren't many games that use it. I know Creatures uses it in the intro. My fighting game is using it. I think is it Quad Exit or whatever it's called. The oh god, what was it called? Quad. Can't remember the name of the game now. The game with the pig jumping around. I can't remember what it's called. C64 game with a pig jumping around. That uses it as well, which gives it a nice kind of colourful aesthetic, which is kind of nice. Okay. Oh dear. Okay. So once you've set your graphics mode, your text or bitmap mode, you can also define whether you want multicolor mode on. So multicolor mode is just another single bit that you need to turn on. This is bit 4 in D016. And this applies, sorry, not bitmap mode, multicolor. This applies to both bitmaps and to text screens. So if you set this value and you're in bitmap mode, then you'll have a high-res bitmap. If you set this value and you're in Quad Init X, that's the one. I'm going to bring it up. If you're in text mode and you set that value, you'll get a multicolor text mode. Quad Init Exit 2, isn't it, I think? Yeah, this is it. So you might be able to spot that it's using this extended background mode by the way that the colours are laid out. Why am I getting this? I keep getting this. What's it doing? It seems to be when I'm streaming I can't play videos for some reason. I don't know why. But you can see here, so you can see how okay, you can't see anything there. Well, anyway, it's basically every square has 2 unique colours, and they're in high-res mode as well. So you get detail plus multiple colours rather than normal high-res mode, which would be 1 colour and a shared background colour. Yeah, I'm not sure why it's doing this. I think I've got some weird settings set up somewhere on my graphics card, because I do have some like weird video acceleration stuff, so it doesn't seem to be accelerating YouTube videos for some reason. Just pause that. So I don't know if you can see that. These are high res, so you can see the squares here. They're square, they're not rectangular. And they're 2 colours in a block. So this block here has got grey and green. This block here has got grey and brown, and so on throughout the map, and it creates a nice very colourful kind of scene. You can see here with the flowers are using orange and yellow, orange and purple, but there's a definite cut off here where it goes to orange and green. So it's just a nice design, but it does limit you to 64 characters, so it has to be quite simple design, which this is. It's reusing a lot of shapes everywhere. and they're using a raster split here to change the bank or something to a different bank, well, to a different character set, which is what we're going to do in the next part of this. So then the final thing to set, once you've got your mode set, you've got your blank selected, and whether you're using multicolor mode or not, is selecting screen, char set, or bitmap locations. So once you've got your bank selected, the Vic has a choice of multiple locations for your screen, for your character set, and if you're using bitmap, your bitmap locations. We can see that in the debugger here. So these are all the locations that the screen can be in. And you can see by default 0400 is the screen location. The default character set location is 1000, which is where the Vic can see character ROM, which is why we get standard Commodore 64 font. When you switch into lowercase mode, it basically the banking just changes it to 1800 and you get lowercase mode, which is what the upper 256 bytes of charrom, 256 characters of charrom do, just lower and uppercase. And you can see again, if I go down to 9000 and 9800, I get the same effect, because these are the locations where the Vic will always see this charram, even if I fill those later. Like I say, if I go to this location, oops, press the right buttons. If I go to this location and I fill 9009FF with 0, I'll show you on here. You know, it's filled with zeros here, but when I click on it in here, I will always see charram. No matter what I put there, I will always see charram. And it's just the Vic that sees that. So to select these locations, you need to set the value in D018. And this is the final thing you need to set up. And if you look at this memory map, it tells you nice and easily how to do that. So what this memory map does is it does everything relative to the start of the Vic bank. So you can see here, it says relative to the Vic bank. So if your bank starts at 0, which is the default one, then this is where you will find the character memory. Thanks for the host, Hayes. And thank you for the follow, Digital Steph, I missed that completely. I must have been on another planet at that point, or maybe I was sorting my wine out. This is yeah. So this isn't the bottom 3. The very last bit 0 does nothing in this location. This is bits 1 to 3, and this sets your character memory. So the default is going to be this one here. So 01 hit 0. So let's build what the default would be when you turn the C64 on. So the bottom 3 bytes, 4 bytes like this. So this byte is completely unused. 010 is the default location, 1000. And then screen memory is this one here, pointed to screen memory, which is the top 4 bits. And you can see here 0001. So that is what is in this location to start with, which is 1, 1, 2, 1, 4. It should be the default value, and it might actually tell us the default here. No, it doesn't actually. But if we give that a restart and go and have a look, we should see that. Why is it not restarting? Oh, there we go. Oh yeah, let's put the music back on. What did I have on? I had this one on. So if we go and have a look at D018. Oh my god, why is it not letting me? Let me restart that. So on a fresh thing, if we go and have a look at 018, it actually says 15. We said 14, but this bottom bit doesn't matter, so that bottom bit can be 1 as well. It really doesn't matter. But you can see that's pointing to those locations. So I definitely recommend using this map to work out which bank needs to go there. And that's pretty much it for Vic banking and how it works. The key thing to remember is that the Vic is always going to be looking at RAM under these locations, with the exception of those 2 Charon locations. It's going to be looking at RAM under these locations. So it gives you 64 kilobytes in which to put your sets. It's worth, if you're doing something that has multiple kind of setups, like a bitmap and a character screen, it's worth maybe separating those into 2 separate banks, because trying to use a bitmap and a character screen and a character set as well doesn't leave you with very many sprites left. So it's probably worth splitting those into 2 different locations and switching between the 2 banks depending on which area, which I think is what Hayes is doing in his game. In fact, we can have a look. Yeah, so he's using this bank and this bank, which is perfect because neither of those banks have that character ROM in them, so you've got full use of the entire bank. Bitmap screen is in this location, character screen is in this location. Really doesn't matter which way around it goes. Actually, it's probably slightly better in this location for the character screen, because then you can keep sprites on the IRM, but it really doesn't matter either way, to be honest. Okay, cool. Right, what I'm going to do, I'm going to try and figure out why my mouse keeps pressing Q. So I'm going to open up this IQ app, which I freaking hate. Oh, thank you for the follow, Tutti Pascal and Retro Gamer. Thanks, guys. I don't know why I didn't hear Tutti Pascal. How do I actually edit this now? Actions. Oh, macro. What's that? Well, there we go. That's what it is. 7. Yeah. Well, I'll get rid of that. I don't need that. That'll be why. I don't know why that's happened. Okay, what I'm going to do, I'm going to take a quick break. When I come back, what we're going to do, we're going to use this knowledge to... I'm going to show you some oddities about the Vic chip as well. And then we're going to use this knowledge to create some effects. We'll start with some simple information and we'll move up towards doing a tech. So I'll create this little crappy character set. I'll explain why it's laid out like this as a character set in a minute. But I'm going to go and take a quick break first, so I'll be back in 2 minutes, guys. Be right back. And thank you for the hosting, though. Oh, guys, freezing out there. That had to be a quick one. Okay, so just to recap, the Vic can only ever see 1/4 of memory at a time, and it's your job as a game coder to tell the Vic which quarter of memory to look at, and within that quarter of memory, where the screen starts, where the character set starts, and if you're using a bitmap, where the bitmap starts. Now I'm going to show you some oddities. So we'll start by just doing a very, very simple program. Oh God, I can't type. Why is that not? Okay. All I'm going to do first is I'm just going to put some characters on the screen. just going to fill the screen with zeros, or I'm going to fill a bit of the screen with zeros. I'm just going to jump to here. So this is basically just going to... I don't know why it's... What's that about? Okay. Okay, so I've created a load of these characters on... What kind of wine am I drinking tonight? It's a bit of a weird one tonight. It's called 19 Crimes. It's a Shard, which is a very, very sweet white wine. So what I'm going to try and do is I'm going to try and change one of the characters here. But I'm going to do it at a very specific point. So what I'm going to do, I'm going to set a loop up which just checks for a specific point on the screen. So we'll do it round about here. And at this point I'm just going to increase the border colour, and then I'm going to wait again for one down here. I'll do it at the bottom of the screen. So what I'm doing is I'm just waiting for the raster to hit this point. It's actually flickering a little bit because it's probably on a bad line or something. Let's change that to... It shouldn't be on a bad line actually. It should be fine. It seems to be missing that bottom one every now and again. Yes, it's missing the bottom one. Let's change it to the F. There we go. We're still getting a flicker. Doesn't really matter. It's enough for what I want to demonstrate. Actually, we can do it like this. We do branch if. Let's get this the right way around. Should be that. Oops. I should probably do this with proper raster interrupts, but I just want to demonstrate a quirk of the Vic chip. That'll do for now. I think it's fine. So I'm deliberately ignore the fact it's flickering. It's the odd frame it's missing. But what I'm trying to do is get a raster that starts halfway through a line of characters here. And the reason I want to do that is what I want to try and do is I want to try and change a character in that location. So if I just change the character, so if I put the letter A in one of those locations, so if I do that at what's this, in the fourth lines, this would be 2850. So this is going to be 78 onwards. So we'll just change it. We should hopefully easily see that it changes to an A. You can see there it's changed to an A. And the reason it's changed is because we've changed it. We're changing it every frame, and we're never changing it back. But if I get to this point and I change it back again, watch what happens. And you see, you don't see the A at all. You don't see half an A. You see the original character, nothing else. And the reason that's happening is because of bad lines. So what a bad line does is it goes and fetches the data for the next eight rows, basically, the next 8 lines of the screen. And once it's fetched, it doesn't matter if you change the value in that location. You won't see anything change there. So you can see it. The only time we actually see it go away is when we get the glitch when it flickers and goes over. So that's important to know, because what that means is you can't change a character once the character has been fetched. So once the bad line has been processed, for 8 lines you are only ever going to be drawing that character. However, what you can do is you can change the bank. So I'm going to get rid of these, and what I'm going to do is I'm just going to reduce this to like to that. So now you can see we're trying to do it in the middle of this line and nowhere else. But what I'm going to do now is I'm going to actually change our Vic bank. So well, not the bank. Actually, we can change the bank. It's fine. So let's do the entire bank. So we're going to change the value in DD0. So the default is going to be 1 1. We'll set it to, let's do something like 0 or something. 0 1. And then we'll set it back to 1 1 here. Actually, has that just grabbed character run again? I think it has. Hang on. So I've fallen into my own trap here. We've gone for this bank, but this bank has character ROM in the same location. So what I should have actually done is this, to show a completely different bank. And there you go, you can see now we can actually change the character data halfway through a line. But the only reason we're changing it is because we're switching the bank. So even though the Vic has fetched the data, what it's actually fetched is the pointers for the data. The offsets, if you like, into the character set, the offsets into the screen ROM. So by changing these values, you can actually change what the Vic actually fetches halfway through the line. And the same applies to changing the character set as well. So if I was to fill the screen with the letter A instead, and then change the character set pointer, which is this one in D018. So it starts as 0 0. What was it? 0 0 0 1 0 0 0 1 0 0. We'll store that in D0 1 8. So that's the original, and we shouldn't see any change if we do this. Okay, I've changed one of that up. Yep, so we've got A's all over the screen. Now if I change this pointer here to point to the next character set up, it's kind of hard to see, but what it's doing is it's actually showing the lowercase a in this location as well. In fact, if I move this line down a little bit, you'll see it doing that. So you can change all the values that the Vic is pointing to. You can change where the Vic is pointing to, but what you can't do is change the values directly in screen RAM. And once it's grabbed the values from screen RAM, that's it. It doesn't change for 8 lines. And that's where Tech comes in. So what Tech is the very first kind of effects that people were doing. They were using the X scroll to kind of create waves, the shimmer that I've shown before, to create waves through the text. But that has a limitation of only being able to shift 8 pixels at a time. So let's set that up. Let's set a Vic bank up. Let's export our character set and set a Vic bank up to show this on screen, and then we'll create a very basic shimmer in there as well. So I've deliberately done this character set like this because I can just draw these values onto screen, and you'll see why that's kind of important when I go to... Oh yeah, sorry, it's quite loud. No, I turned it up for the Tetris thing. There you go. Hopefully that's a bit quieter. So let's export that character set. I'm going to call it chars 0 because I'm going to need multiple of these. And I'm going to actually store these in 4000 onwards. So let's go through what we did before. I'm not going to turn the kernel off or the basic ROM. We don't actually need it for this. We'll do everything in now it's off. It shouldn't be off. It should just be a bit quieter. There it goes, up a little bit more now. So let's go through again. So what do we need to do? So select a bank. So what we'll do, we're going to put character sets here, and we're going to have our screen, which I'm just going to call and I'm going to put this in the very last location here. So these are the two things we need to set up. So we're using VicBank 1, which is this one here, which means these are the two values that need to go at the end of DD00. So you can just do it like that if you want to, but I like to use the whole 8 bits, so it's obvious. So that selects the right VicBank. Now we need to select char and screen location. So character location. So our character is at the beginning of the VicBank. So again, if we have a look at our memory map, we can see here pointer to character memory relative to the VicBank. So that means we're at the beginning of the VicBank, so this is the location. So the bottom 3 bits need to be 0. Bear in mind as well that the very last bit doesn't get used. So this bit here, this last one, doesn't get used. So it's actually bits 1 to 3 that we need to set. And the screen location is the very last location. So 7C100, which relative to the big VicBank would be 3C100. Which is this one here. So you see pointer to screen memory, the very last one, which means we set all 4 bits here. Store that at P01A. And then we can set our graphics mode. We want text mode. It's worth looking in here at the various things, but basically the default is 1B, and 1B is text mode, so you might as well just store the original default value. This will already be set, but we're going to do it again just to be explicit. Oh yeah, you can't hear the typing anymore, can you? Is it strange? So like if I turn, where is my RTX filter? So if I turn this off, see how it changes now. So now you can hear it, I guess. But you can probably hear my fans as well. Actually, no, I've only got one of my fans on, so you can hear me clapping. I love this. I think it's a brilliant piece of tech. And then turn it on. I'm going to keep it on because it does make it a bit clearer, so makes it much better for the YouTube streams, the YouTube uploads. It is kind of like magic. It's incredible what they've managed to do. It is smug mode. Okay, and we need to set multicolor mode and colors. And so to do this, we need to turn on a bit in D016, which is bit 4. So we'll load D016, we'll OR it with that bit there, and then store it back. So that's now turned multicolour mode on. And then let's set some colours, so we'll set a background of black. And I believe the character set uses white throughout, so we need to fill... I'm just going to do the top part of the screen, but for now let's just get rid of this chunk of code here. And let's just see what that actually prints. You should see now that it kind of puts us in the right character mode, and there you go. So it looks weird because we've changed where the screen RAM location is, and because the screen RAM is pointing to somewhere different, we're seeing whatever is in RAM at that location. So still got your heating on. No, this room gets hot, so this room is actually, it's only at 24 at the moment, so it's not too bad, but it can get up to like 30 or above. The thing is, this computer is very good at expelling heat, but unfortunately the heat has to go somewhere, and it goes into my room. So while the computer's really cool, I'm not. Also, this screen's quite warm as well, so a lot of heat. Okay, so let's fill the screen with some blank space. So let's have a look at the character set. Let's just do the last character in the character set. I think it's probably the safest way to do this. Oh my god, there we go. I keep forgetting how to use Sublime because I keep switching between different programs. So now we should get a blank screen. Perfect. Now, what I want to do now, and I'm just going to do this with an unrolled loop. Just because it's easier than writing the code out manually. Basically, I want to print 32 characters on the screen with a gap of 4 on each side. So I'm gonna yeah, we'll do it. We'll do this. It really doesn't matter how efficient this is. So a 2 3D print. Yeah, I've got a 3D printer back there. I need to set that up again because it's really good. I need to do some more stuff with it. Pump the water cooling through your heating pipes. Yeah, actually, it would be pretty good. Actually, the water. Actually, no, because the problem is the radiators expel the heat so fast that the water actually doesn't get that hot. Okay, so I want to load, so we're doing 8 rows, so that means there's 32 characters on each row. So we start with the value like that. Start with x is 0. I'm going to store that at screen RAM. It's whatever the row is. Plus 4. X, and then I'm gonna clear the carry bit here because I don't actually know. I'm gonna clear it here because we're gonna do a comparison. So I'm gonna add 1 to it and then increase x, compare x with 20. So there we go. Right, so this should print, hopefully print tech on the screen. Cool. Doesn't matter that it's over to one side, that's fine. And it skews the shitty graphics. I did this just before the stream, so it's not exactly the nicest graphics in the world. So yeah, but you're using an all-in-one cooler, so and yeah, I mean, the reason my room gets hot is because I'm running a 3950 and two 2080 Ti, so it's a hell of a lot of heat to pump out of the bloody thing. If I turn the PlayStation on in there as well, the back of that computer gets so toasty you could probably cook stuff on it. So the other thing we need to do is just set some colours up as well. So at the same time as doing this, I'm actually going to move this into here. I'm going to store 0.8 because we're in multicolour mode. We need to add 8 to our base colour for the character to get the colour round correct. So hopefully this should just fill with white, and now I just need to set the other two colours. So white is one of them. Hang on, is white one of them? No. That should be 9, that's right. And this should be like grey, and this one should be dark grey or something. I don't really care that much. Oh, yeah, that's fine. It's perfectly fine. I'll just knock that down to a different shade of grey. Cool, there we go. So actually, I am going to turn kernel off because I'm going to do some interrupts. So I'm just going to do my normal. Set an IRQ up here. So so this is the banking that is actually going to turn the kernel and basic off. And we'll start our effect at 3 zeros. Kind of probably a bit early, but it's a good enough place to start. Oops, no, this needs to be... Oh, my headphone's gone. Which... Fine, we need to enable the interrupts and acknowledge them. Okay, and now we can have an IRQ down here somewhere. So I'm going to create an IRQ here, and I shall I'm just going to acknowledge it and return here. I am going to put an increment in just to make sure that it's running. Okay, so we've got it printing on the screen. We've got an IRQ set up that's starting here. So what I'm going to do, the IRQ is going to do a few things, but the very last thing that it's going to do is it's going to set up an index into a... Actually, we can do it quite easily here. So if we create a table, we can call it sinus table. And I'm going to fill this with 256 bytes, and that's going to be sine values. Times 2 by 6 times pi times 2, that's correct. Times 3.5 plus 3.5, so that should go from 0 to 7 now. So this sinus is 0 to 7. And then what we can do here is we can have a sinus index, which is just going to be a single byte, and we're just going to increment that. So the first thing we're going to do is we're going to increment the sinus index. and we're going to load it. And then every line, what we're going to do, we're going to do the same block of code. We're going to try and keep this as short as possible. So the first thing I want to do is wait till we're on the next line. So while we're on the same line, we don't do anything. And then what we're going to do, we'll also, number of lines will store in Y. So we'll do this over, we've got eight rows of 8 characters. So we'll do over 64 plus about another 8. So let's do 72, which is 48 hexadecimal. Okay, so we're going to wait for the line to be on a brand new line. Then what we're going to do is we're going to load sinus table, comma X, and we're going to store this in our horizontal scroll. So our horizontal scroll is in D016. So what we need to do is we need to take the value that's currently in there, get rid of the last 3 bits, set the next 3 bits, and then store it D016. And then increase Y, and if we've not hit the end, jump back to there. Now, hopefully this works. It might be, timing-wise, it might be off. No, it's... What's it doing? Oh, because I also need to make presets. It's not quite right. I think it's not quite right because of the sinus table. So if we do this, so there we go. We have a bit of shimmer going on there. We're seeing some weird stuff here, and I think this is due to some unwanted effects. So I'm just gonna, if I do that, what are we gonna get? We get 3.5. I need to check that table. I just need to see what's in that table just to make sure it's not. See, we're getting oddities in here. Can you save that as it is? All right, I'll do it. Let me do a commit for that. let me fix it first, and then I'll save it. You see how it's changing? Each frame is changing. I need to figure out why it's doing that. I think it's. It shouldn't be filling that screen with anything other than that. If I don't do that effect, it should be fine. Oh, I know why. Transfer X to the accumulator, push. Keys for allows the accumulator, push. I wasn't saving any of the registers, so it was probably what's causing that. There we go. I mean, it's not perfect, but you can kind of see how it works. And if by changing this value here, we can change how often the effect happens. So I'm going to save this as it is. Oh, thank you for the follow, Proper Trucks. Proper Trucks, cool. So let me get rid of that the border flash, because we don't need that anymore. And there you go. So this was the original kind of the original way that people did this kind of shimmer effect. Now comment it all. I think you can. I think we've done enough now that you guys should be able to figure that out. It's not a huge amount of code. I think you should be able to figure that out. this is the magic here. This is this block of code that's doing the magic, and most of this you have seen before. This is the only bit that's actually running the shimmer. Okay, let me commit that into. Actually, I have never actually opened this directly in source tree, so I'm just going to drop it into. The Airwolf August video, no. I have to look at that. So, Dissect game, episode 27. So I think if I just drop that on there, it should upload it. I'm not going to put any comments in this. I never do on these things. So. Cool. Right, that's uploaded now. So it's a nice effect, but you can see the problem with it. The problem is that it's never going to shift more than 8 pixels in any direction. The shimmer is only going to happen over those 8 pixels. So what people worked out is you can use the Vic banking techniques to shift it further. And the way they do it is really, really simple. So we're going to shift it 32 pixels instead of 8. And it's a really, really simple technique. Basically, what you do is you take your character set and you arrange it in this way. So you draw into the character set like so. And then you shift the entire character set over by 1 character. And then you export that as a new character set. And then you shift the entire character set over by 1 again. Then you export that as a new character set. And so on. And you can do this as many times as you want. You can technically do it 32 times. Well, 31, I guess, because you still need to have a screen to do it on. But we're just going to do it 4 times. But if you switched went through all the Vic banks, then it would be there. Yeah. Let's have a look. Let's see if it should run it. I don't know why. It seems to just be when I'm streaming for some reason. 4K. Oh, I wish it was 4K. It's a bit more than that, unfortunately. Where is it? I can't see it. I'm shifting, so this is the actual character set. So the logo is just drawn directly into the character set. So all I'm doing is I'm shifting the logo data over by 1 character. How many have I done now? So I've done 4 apparently. So let me just check that I've actually got 4. I haven't, so I need to export this one. So you can see this is the character set on one side, and if I import the character set from the beginning, oops, it's over that side. So all we're doing is we're exporting 4 character sets, 1, 2, 3, 4, like that. Well, you can have more. I mean, you can do this with bitmaps as well. So if you wanted to, you could use 4 different bitmaps or more, depending on where you want to put them in memory, how much memory you want to use, and you just shift them over a little bit at a time. And Airwolf music comes on. That's funny. So the change we need to do now is that we need to do a little bit more than just setting these values here. So what we need to set is we need to set a value in D016, but we also need to set a value in D018 to tell it which character set to jump to. So first of all, let's just import all the character sets. And the easiest way to deal with this is to not have to kind of do all this here, because this is going to take too long. You don't have a lot of time to do this block of code here. You certainly don't have enough time to do character set switch and the X scroll as well, because every 8 lines you're going to get a bad line, and on a bad line you're only going to have about 20 cycles. So the way that this is normally done is with 2 tables for both values. You just read the value directly from here, put it into the 3. So it's exactly the same as this, but instead of 3.5, so this is what gives us 8. So we go from 3.5 to 3.5, which is 7 plus 1. So it's basically the total here plus 1. This is 8 pixels. We want 32. So that means we need to do 15 on one side, 15.5 on one side, 15.5 on the other side. This will give us from 0 to 31. However, what we need to do now is we need to just, for D016, we're only interested in the lower bytes of this. So we're going to end it with 7, because we're only interested in those last horizontal scroll values. And so that's the value we're going to put in this side. And then we're just going to add the original values into D016. We don't have to do, we're going to pre-calculate these values basically. I don't know why Linus was on the screen then. So let's have a look. So D016. So our default is C8. We have turned multicolor mode on. So this is actually going to be D8 plus the values. So this is going to be D8 plus value. And I'm going to wrap it all in these nice brackets. There we go. And then the D018 value uses exactly the same lookup, but instead of ending with 7, now what we need to do is we need to get the next 2 bits along. So we need to end this with what's this going to be, 1/8. Let's do this all in hexadecimal so it makes more sense. And then it's going to be shifted by 3, which is going to give us 0 to 3. And then this value becomes the value that we put into D018, which is this one here. And what we're selecting is this bit here. It's actually these 3 values here. So we'll keep this bit the same. So it's going to be F0 here. We're just going to shift by 2 there actually, because we don't need to fill the last one in. And that should give us our D018 value. And now all we need to do, hopefully, if this has worked, is we load sinus D016 and store it there. Sinus D018 and store it there. We don't need these values at all. You can see it's scrolling much more, but it's obviously a lot harder to read there. So let's slow that down a little bit. So let's make a constant here. I never use constants, but I'm going to here. Let's call this shimmer factor, and let's make this 128 to begin with. And we're getting a little bit of glitch, and I think this is to do with the timing of the lines. So we'll try and fix that in a minute. You can see now it's moving much more. It's moving much further across the screen now. Okay, I think the timing of these lines means that sometimes we're getting some glitches in here. I think that's what it is. I need to make sure that it's not these values. I don't think it is. In fact, I can go and have a look at those tables. First of all, let me align those. Just go and have a look on it. Zero B100. Okay, so let's do it in the debugger. It's a bit easier to see the values. I just want to check that those values are correct. You can see here what's happening. The character set is changing. You can see on this bit here. As I move up and down, and the result is that we see it moving a lot further across the screen. And just before we fix it any further, if you wanted to, you could. Oh, why have we not seen that? Okay, for some reason the character set has disappeared. There we go. There's 8 potential character sets in a bank. We need a little bit of space for the screen itself, so we could add another 3 in here. So let's just try adding another 3. So it's 1, 2, 3. There we go. And 3 more down here. And now we just need to change these values. So this was 32. We've added 3 more. So this has now become 56. So that is 27.5 on both sides. Again, you could probably do this with constants up here. I think we've got a bug in there somewhere. 27.5, is that right? 55. I feel like that's not right. See, I want to deal with 5.6. Right, what did I have this at? 15.5. Is that right? 12. Yeah, that should be right. Okay. So if we did it with less, so let's try it with 3.5. Let's try 19.5. I'm doing something wrong here. What is that? 32. 32 is minus 1 is 31. Halved is 15.5. And that's 32 is 8 times 4. 8 times 7 is 56. 56 minus 1 is 55. So it should be 27.5. Yeah, I don't know why that's not working. What are you doing? So what are you doing now compared to earlier? It's more efficient this way. No, it's moving further. So the original code was only moving 8 pixels at a time in either direction. This is moving many, many more. This is moving, well, as far as you want it to, really. It seems fine in this mode. There is a glitch. I'll get rid of that glitch in a minute. I don't know exactly what's causing it. We can look into why that's happening. It's probably a timing thing. Almost definitely going to be a timing thing. I'm just wondering why it's not allowing. Have I got character set 5 wrong or something? So we're doing these 3 and then this one. which is 4. Yeah. Well, this should be right. I don't know what I'm doing. I think the data's wrong somewhere. Yeah. Okay. I think this data's wrong. So you could flash the colors also. Yeah. I mean, one thing to bear in mind with these as well, and this is why you will see with logos like this, that the colors tend to be in horizontal bands, is because you are basically shifting the data across the screen. The color RAM needs to kind of be the same across each row, because the characters are moving through it. So if you had different colors for each of these, you would have to shift the colors with it as well, and that becomes impossible to do properly. So you'll see bands of colors in these usually, or one kind of mono color throughout it. I'd love to know why it's not smooth. I think we're hitting a glitch. I think this routine here is not perfect. It's not an ideal way to do this. You could also do something. Actually, no, can't. Can you? Okay. Let's try moving that to here. Maybe that might work. I don't think it's going to make any difference, though, to be honest. Yeah, in fact, it's made it worse. I think that is the problem. It's to do with the timings here. Sometimes what you'll see is that even these values are worked out before you get to this line, but we're using all the registers here, so we could probably change this around a little bit. I'll have a go at doing that in a second. I just want to work out why when I extend this to this value, we're getting a glitch halfway down. So I'm going to run it in the debugger and see what happens. Use HL, yeah. So let's just pause it. Okay, so character set. And then it jumps back to the top again. I think... Wait, this should be fine. Yeah, I need to check those tables, don't I? Let's go and have a look at what's in there. So this is our normal table. Actually, it looks, you can, oh no, this is the screen. This is the character ROM data here. It looks kind of normal, but I think we're not seeing. Hang on, it would be too. Do you know what, I'm just gonna, for now, for testing, I'm just gonna do it like this. I know it's not gonna look right, but I will actually see in memory what the values are. So it's gonna do all sorts of weird shit here now. It's actually kind of scrolling correctly up there though, but I'm just doing this because I want to check the values in these locations. Yeah, there seems to be a break here. It seems to go from 2.4 to 6. I think there is something wrong with this second one here. Oh, I know what it is. It's because actually we were just grabbing the upper 2 bits and it's not that at all. So what I should be doing is handing it with F8 like that. And then scroll it. We need to grab all the higher bits. So let me still do that. There we go. That should solve the problem. There we go. Right. So now all we've got is the glitch, but you can see it's going much further across the screen now. And you can extend this further as well. So if you wanted to, you could add a DD0 thing in here, so you could actually switch into different Vic banks and put even more character sets in other Vic banks as well. So at the moment, all our character sets are in this location. But what you could do is you could, for instance, move the screen round to the beginning and have from 400 onwards all the way through the upper memory, all the way to the end with just character sets that are shifted across. You'd have to set another value on here. Hey Splod, welcome to the stream, dude. Okay, let's work out why we're getting that glitch. Now, I think that glitch is happening because of this comparison here. It's not very efficient. And the problem is by the time this has happened, this might be too late. So what we can do, we can kind of pre-calculate these values and then store them, which might solve the issue. So if I just get rid of this, for instance, do we get less of a glitch? If there's less going on, is there less of a glitch? Let's do it actually in there. Okay, I mean, obviously it's wrong because it's not shifting across, but you can see now it's not, we're not getting any of that weird flickering through. So I think the problem is the timing of this phrase. So I'm going to try setting that a bit earlier, try setting that first. Try setting on the line before maybe. Oh, because that probably needs to be. Yeah, that's not helped at all. Yeah, the problem is with the, yeah, exactly, Buzzy. We could do it with cycle exact, but the problem is the bad line. We're always going to have the bad lines that we need to deal with. And I'm not a demo coder, so for me this is kind of uncomfortable territory. I've never actually done a tech before. I just know how they work. This is the first time I've ever done one, so I just know the concept behind them. Actually, that's not entirely true. The rolling road that I did was kind of a tech effect, so so I have done something similar. I'm just thinking if there's a more stable way of doing this. So one thing you can do is have these values already stored somewhere. And in fact, it's just this value here that we need. So what I'm going to do, whoops, I'm going to store this in 0 place. So I'm just going to store this at 02. Create a label here. Just make sure that still works. I can't remember if the I think the 0 flag does get set on that, so it's just okay, cool. So now we've freed the Y value up, so we can use the Y value instead. So what I'm going to do is I'm actually going to grab this value here. I'm going to load it like that, and then I'm going to store it like that. So it's going to save us a few cycles at the beginning of the line. Still not enough, and you can see it is kind of on bad lines that it's happening as well. It could even be something as simple as just kind of knocking a few times. This can sometimes get rid of these glitches as well. So what happens if I just knock a load of times here? So now it's only happening on one half of it, it's not happening on the other half. You'll see what I mean about adding knops does strange things. Let's do a couple at a time. Let's do one at a time and see what happens. So that's one. Oops. Let's try. Let's try extending that a little bit. I can't see this having an effect. Oh, that's doing. Don't like that. Don't like what that's doing at all. So you could probably fix this. See how it's only on one side. So if I was to just change this to that, so it's mostly gone. I've moved it over to the side and it's mostly gone. Let's put it back in the middle. Let's just add another knop. I'm just going to keep trying the knop thing until I find the position with the least kind of interference. No, see, we seem to be increasing it as we're going across now. Okay, so let's try getting rid of that, and let's try let's try this. Let's no, that's not the way. Let's try there. See how it works. Ooh, what's that doing? Because that man needs to do. Trying all sorts of crazy stuff to get this to work. Yeah, let's try moving. Let's try doing the D016 first, and then maybe put some knops between that and that. See, it's proper demo coders would be looking at this thinking, ha ha ha, so easy. What are you doing wrong? I think the biggest problem is this. This is so unpredictable. It's not ideal at all. I'm trying to think of a neater way to do this, but I can't really think of one. Because the problem is I don't know if I'm on a bad line or not. I think this definitely needs to happen first. Maybe this is taking too long here. Let's have a look. So it's, what would this be? This would be 4, this would be 3, I think, cycles. So essentially it could be 6 cycles out, which means we've only got like about 14 cycles to do our stuff, but this is definitely less than 14 cycles. This is 13 cycles, 12 or 13 cycles. But then if it's a bad line, this is going to be delayed. So this is not going to happen straight away. It still wouldn't be enough time, I don't think. It would still. This is the problem. This block is on a bad line. This is taking longer than we actually have. So, ideally, what we need to do is make sure this is shorter on it on every line. Oh, hang on. Yeah, I mean, shifting it all over to the right does work. No, I've deliberately aligned. I think the problem is, and you can see it kind of with where these are actually occurring. So they're always occurring in the same place. So if I move the arrow, you can see they're always occurring on that line. They're occurring on bad lines. And the reason they're occurring on bad lines is occasionally this can take up to about 5 cycles off the beginning of a line, which means on a bad line you don't have many cycles left, and this entire thing is taking more cycles than we have left. I'm just trying to think if there's a sneaky way of avoiding this. One thing we could do actually is if we just did this. So we only do every other line, so we do 2 lines at a time instead of 1 line at a time. Then we'll avoid the bad lines. So what I'm going to do, I'm only going to do, hang on. Game Boy Color would be a lot easier actually. In fact, Game Boy Color doesn't even need to do this, because on Game Boy Color you've got scroll window. So it'd be very, very easy to do. Take a lot less time. And wouldn't need any crazy bank switching. In fact, it's how they do all the Rolling Road games, because you've also got scroll Y, so you can move the screen anywhere. You can draw any line of the screen anywhere. Pretty much within reason. So I think what's happening is it's the bad lines. So I'm just going to skip the bad lines basically. So I'm only going to do every other line. So we could do this twice. That might actually just be enough. And so the effect is going to lose some of its vertical resolution. But now bad lines won't be counted. So we're getting a problem at the top, which is probably just because we're starting it at the wrong place now. So if I go and change the start location, which was in, so if I just change this to 2E, whoops. There we go. I mean, it's still not perfect. There's still a little bit of glitching going on, but you can see it's kind of a little bit better. And we can get the original kind of wave back by changing the shimmer factor. A lower shimmer factor means less. It's the gap between each one. There you go. Cool. And that's kind of good enough for me. I'm going to shift it over a little bit because 2, 3, 4. Yeah, I'm going to shift it over by 2 characters. I think should be enough. Cool. I think that's about right. Alright, I'm going to go for a quick smoke. When I come back, I'm going to show you how we can use actual VIC banks switching to do a bit of static on it as well, so you can create a kind of nice effect like it's a VCR or something. Hey Thalamus, welcome to the stream. Yeah, Game Boy Color is definitely, the more and more I look into it, the more I realise they obviously looked at the architecture of the C64 and the way that the interrupts work and the way that the chip works, and they took some of the cool stuff from that, some of the cool stuff from the NES, and they combined it into this awesome little machine, and then they hampered it by giving it a Z80. What they should have done was give it the 8510 from the C128, but with the video capabilities that it's got. So, all right, I'll be back in 2 minutes, guys. Be right back. And I'm back. I think I stopped the music then. Oh no, it's back. Okay. So this is how we can use the char sets in a given VicBank to actually tell the Vic to fetch different data. As I showed earlier, if you try and just change a character in screen RAM, it's not going to work. So you have to use tricks like this in order to do these things. And other than the bad lines, which I'm sure with a bit of work and some better timing, we could get it to work on a 1 pixel high resolution instead of 2 like this. But this is a good example of how it works, and you can see in the, if I show you in the debugger what's going on. See, never try and resize the debugger while it's loading up. Let the debugger load up, let it go through all its crap, and then give it a resize. Of course, actually load your program into it as well. So you can see what's happening. It looks like we're scrolling it across the screen by multiple characters, but we're not. It's just the character set. You can see the character set moving here. See it switching between them. And it creates that effect. As I say, you can extend this beyond the VicBank you're in as well. So you can, and what we're going to do next is actually change the VicBank halfway down. But we're not going to do it to create the effect of an even wider tech effect. We're going to do it to create a static effect in the middle of the bank. First of all, I'm just want to see what happens if I just increase the frequency. Okay, so yeah, you can get it like super crazy or very subtle, or even more subtle. I'm pretty sure if we do that at 256 it'll be super subtle. Barely actually happening at all. So I think 64 is the right value to put in there. It's enough that you can still read the text. Okay, so what I'm going to do, can you make it 1? What do you mean? Okay. Oh. Interesting. Why's that doing that? Oh, because the values are never actually there. There you go. 4 is the first one. It's just happening so quickly that it does nothing. Let's go up through the values. Yeah, 64 is definitely the one where it seems to fit the best. But you could create a nice effect where, you know, you start off with this value here, and then you gradually reduce it, so you get an image that starts shimmering slightly and then kind of distorts and disappears. what was the first year? It would have been pretty early, I'd imagine. Is it Atlantis Prophecy or something? No, it's not Onslaught, is it? There is a really good list of them somewhere. Don't know where it is. Somebody posted it actually the other day. But I would imagine it would have been quite early on. I would have probably say very early 80s. Yeah, this doesn't have any of the... I thought it was this site that has it, but it's not. Maybe it's just Atlantis Prophecy. That's not that either. Okay, I don't know where it is. Somebody did post a link to them all the other day in Discord. I can't remember who it was or where it was, so I'm not going to go looking for it. But there is a history of all the kind of graphical effects and when they were first done online somewhere. You can go and check that out. So what I'm going to do, I'm going to put another one in here. And it's not really a sinus, but I will call it oh, maybe it is that one. Hang on. Thanks, Stepz. World of Demos, World's First Effects, AGSP, different Y, flexible line. These are all FLI. Yeah, these are all the kind of fairly advanced effects as well. I don't think anything's got the crunching, no. But I mean, you get an idea. These were done 1989 for flexible pixel positioning, so it would have been way before that. It would have been one of the first things. You can run a bad line up the screen. You can't really run a bad line up the screen because to do that you would have to force just a single bad line, and that's not going to be that easy to do. So what I'm going to do instead is I'm going to use this effect. What I'm going to do is I'm going to take, actually I'm not even going to do it. I'm just going to call it static like that. And we're going to take the value that we put in DD00, which is 10, and that's going to be our main value that we're going to fill this array with. But what I'm going to do is I'm going to fill it. I'm going to do 62 bytes with 10, and then I'm going to do 2 bytes with a completely different bank. So now I'm going to point to let's do the upper area of RAM up here, like so, and then I'm going to repeat that, like so, and then it is really as simple as doing this. So not brilliant. Let's put our shimmer factor back to 64. Okay, so what you're seeing is a VIC bank being selected that isn't in the same area as what we're seeing on the screen here. So two things we need to do. We need to make sure that the VIC bank gets set back to the right value at the end here. So when we exit, we always go back to 10. That will get rid of the glitch at the bottom of the screen. You see now it's just coming across here. We'll reduce the the frames that this is being shown on. So we had, where was it? This value here. If we reduce that down, 20 or something. Not sure if that's going to be enough. There we go. And so at the moment it doesn't look very static, and that's because what it's doing is it's grabbing values from C0 onwards. And the thing is, if you look in memory at that location, 1988, wow, I would have thought it would have been earlier than that. I'm surprised, actually. I would have thought it would have been a lot earlier than that. So we're going to have a look in memory at this location. It's actually down here. You can kind of see from this memory map it's not very random at all. It's just zeros and FFs throughout the memory. So what we can do is, if we just come down to here, and we're going to fill this with 3FF8. We can't fill the entire thing. We're going to fill it with random data. And you can see now we get that static effect, because now the data that it's pulling in is actual random data. So there's a little bit of a glitch underneath it. So let's slow it down and have a look what's going on. It's just so slow now, isn't it? Had to complete Airwolf. Where's the pause button on this? How do I pause this? Can I pause it down here somewhere? Pause emulation, Alt P. There we go. So it seems to be screwing up when it comes back to the normal Vic bank for some reason. So let's try moving that to a little bit earlier. Let's do this here. Getting those glitches in it now. It actually doesn't look too bad, because it's kind of what you'd expect from a VCR doing that kind of effect. And you can see how doing this too late is bad, so we have to do it earlier. So actually it doesn't need to be, it needs to be the last thing, otherwise we'll get a glitch. But yeah, there you go. It's kind of moving up the screen. And if you wanted to make that static a bit more frequent, then you can change these values here. So if we make it a bit thinner, do this in a loop just so I don't have to repeat myself. No, well, there needs to be more frequent than that, actually, so let's try. Yeah, there we go. So we're still getting weird bank issues underneath. So if I pause, it's fine. Actually, it's kind of fine when there we go. So what's actually happening here? So this looks like, I think we might be getting an FLD effect here. Sorry, not FLD, a VSP effect, because it looks like it's shifted stuff across the screen. Because there's no Hang on, let me think about this. Or is it just grabbing? Maybe it's grabbing incorrect screen RAM. Maybe. So it looks like it's an entire character's width. So let's think about it. So it switches bank. And then reads the data from that bank. Okay. So actually what we need here is we need a copy of that. So what's happening is it's reading the data in the screen RAM up at the top. And so what I need to do is I need to fill the top of the bank. So I'm going to fill this 0 like that. I'm going to polish shadow screen RAM, and this is going to be at FC0, and then in here now this has to be, hang on, that should be right. Okay, oops. Okay, the only problem we're seeing now is these gaps down the sides, and that's because this bit here. So we just need to fill 2 rows extra with this. So what I was saying before about when the bad line happens, it grabs the data in the screen RAM. So if you're in another bank and you hit a bad line, then it's going to fetch the data from that screen RAM, not the screen RAM you want it to grab. So when we switch back, what it's actually drawing is the data from the other screen RAM. So we need to make sure we have a copy of the data that we need. And there we go. And now we've got static lines that are actually moving properly up the screen with no flicker in there at all. Cool. Good night, cheers. Thanks for joining the stream, dude. Full screen interference effect like a black and white TV station not tuned in. Well, you can do that quite easy. So this piece of code here, we've already filled that in. I will very quickly show you how to do that. So this is doing a tech. So let's just turn that off for a second. And before we do the tech, so I'm going to actually set the IR keys up here. But before we go into that, what we'll do, move all that down here, just make sure this works properly. Yeah, let's do that there, like so. Okay. So in order to do the effect you're talking about, what we need to do is, first of all, we'll set the Vic bank to be let's actually fill from here. So there we go. 7C100. Yep. So I'm going to fill shitloads of memory now with random data. Then what I'm going to do is I'm going to set the Vic bank to be which bank is that? Is that the last one? No, that one. And then we're going to set our mode. Let's just make a static screen. So our mode is going to be bitmap mode. So this one here, bit 5. So we need that to be on. So that becomes a 3B in here. and then we'll select our screen location and our bitmap location, so we'll keep screen location where it is, and our bitmap location will be 0 or 1. Okay, so this becomes 0 or 1, so we'll put 0 in here. Set the background to black. And then we're going to fill the screen RAM with white. Color RAM with white, sorry. Just want to see if that's actually doing the right thing. No, it's finding... Oh, see, this is the problem. It's finding character RAM in here, and it's still grabbing the screen RAM colors from here. So actually, color RAM is no good, and that the lower bitmap is wrong as well. So we'll just use the upper bank. So we'll use this one here, in which case we need to set the screen RAM, which is at FC 100, FD 100. There we go. And then, I mean, you would do this over more screens, but I'll just do a double screen one here. So all we need to do, we'll set a counter, which we'll put in X. And then all we need to do is toggle the bit in this. So, sorry, not that bit, in D018, here we go. And the bit we're toggling is this bit here, this top bit. So we need to take that top bit, obscure it, so I'm just going to store that in temp, like so, and then or it with temp. Is that not working? It's picked up the colour RAM again for some reason. D018. Turn offset. So that's fine. But then when I switch to the upper bank, you know, I could just do it really simply like this. Let's just check that that one looks alright as well. So we get a bit of a glitch down here. This is because this is actually screen RAM that we're seeing down here. So we'd probably cover this up. Or you would flick between 4 different banks. But let's just look at the top half for now. So if I do... So it's just flicking between 2 banks at the moment. Then you could probably add some random scroll values in as well to to make it change. I guess it's got more greys and stuff in it, hasn't it? So it's also very predictable at the moment. You could also have it filling that data all the time with random data as well. So when it's not flicking between the two frames, it's filling random parts of that screen with random data as well. So each frame is slightly different. Actually, I wonder how would that work. Could I? Yeah. Okay. I think yeah, you could definitely do it. But that's kind of how I do it anyway. So is this a C64 pick? Let's have a look. Fuck's sake. But yes, it is. Stepz. Naughty Stepz. I should have done. I should never click links. I should never click links on my main screen. Should always check them on the other one. Yeah. It's too late now. Banned. Yeah. Okay. I think I'm probably going to call it a night there. It's a little bit early, but I think we've kind of covered what I wanted to cover. I'm going to get rid of this block of code here because it's not needed. Just to leave that there. But yeah, I mean, you can play around with this quite easily. So just changing the interference. So if you want to change the shimmer factor, just up that value and it will wobble a bit less. If you want to change the interference pattern, just mess around with these values here. So if we change it like that, make it a bit wide. Let's make it super wide. Let's make a really wide effect. They just need to total 32, so do 28 here. Go. It seems to be appearing a little bit soon, so let's change that as well. So changing this value here will change where it starts on the screen. There you go. Actually, it's 24, and let's shrink it down to 2. I like it at 2. It's better like that. And you could do something like you could make it go the other way as well if you were. Let's try and make it go the other way before I finish. So this is the value we're grabbing here. Probably we need to put it back when we finish, so might be a bit too much going on here, but let's try it. Oh, why is that not going the other way? Surely that should be going the other way. Should that be going the other way? I feel like that should be going the other way, but it's not for some reason. Anyway, it doesn't really matter. I'll leave it as it is. Okay, cool. I think that's it for tonight, guys. Let's find someone to raid. A bit of a short one tonight. Still feeling a little bit tired, so probably good to get to bed a bit earlier. If anybody's got any suggestions on who to raid, let me know. And if anybody has any questions about any of this code tonight, it will be in GitHub after this. The usual place. Check my my Discord if you want the links to that. What's Jessica doing? Just playing Tabletop Simulator or something. Is Carla on? Why don't I see Carla? Why am I not seeing Mr. Cola? What the hell? Oh yeah, there he is. Why haven't I seen him? I'm not following him. I was like, oh yeah, let's go and raid Mr. Cola. Okay, cool. Cool. Alright, thanks guys, thanks for coming along tonight. We will continue the game on Saturday, all being well. Yeah, cool. I'm glad we managed to get this working with a nice static effect as well, and you can see it's really useful knowing how to kind of switch the banks around, not just for your game but for doing kind of additional effects like this. Alright, cool. Thanks guys. I shall see you all on Saturday. Take care. Bye.